Hey there, fellow tool nerds. This is Doug, the professor, coming to you from my lab. And today we're going to continue on with my current obsession, which is not using vinegar to remove rust from tools. Now, in previous videos, we saw that vinegar does remove rust, but it also removes metal, which means it causes damage, and we shouldn't use it. But it's still kind of an attractive option to a lot of people because it seems fairly safe. I mean, vinegar is something that we put in our food, so it can't be that bad for us. But anybody who's ever tried to clean up rust with vinegar knows that the vinegar goes from being this nice, clear solution to being kind of a dark, murky mess. And that liquid needs to be disposed of eventually. But how? I mean, do you throw it down the drain? Do you toss it in the backyard? What happens if your dog gets a hold of this stuff? So today, that's what we're going to be exploring. Now, I have access to some pretty sophisticated equipment in my laboratory that will allow me to figure out exactly what's in that sludge that's left behind in those baths. Now, ideally, I would get an old vinegar bath that's been used for months, if not years, and analyze its contents. The problem with that, though, is that those mixtures can be kind of troublesome, kind of difficult to work with. So I think I'm going to simplify things a bit and try to mimic the effects of one of those baths, but using a much stronger acid so that I can quickly break down the metal. So the acid I'm going to use is hydrochloric acid, and I'm going to hopefully be able to see what kind of things get stripped out and into the liquid phase when they've been sitting in acid for a long time. As you can see in this time-lapsed footage, the hydrochloric acid is acting on the metal in a very similar fashion as vinegar did. So we see bubbles being formed, so we're producing hydrogen gas, and we're starting to see some darkening of the liquid behind it. So it's taking on sort of a greenish tinge, and you can see some materials kind of falling off into the bottom of the flask there. So overall, very similar to what we saw when we were working with the vinegar. All right, so what I'm going to do here is I'm going to test for the metal content of the sample. So as you see here, our sample is being drawn up this tiny tube via a peristaltic pump and sprayed into our nebulizer, which produces very tiny droplets. Those droplets then get carried up into a plasma torch, which is at a temperature about 3 times that the surface of the sun, which energizes any kind of metal ions present, causing them to give off light. And it detects that light and uses that information to figure out what metals are there and how much. All right, so I looked at a couple different metals. I started looking at zinc and copper because they're alloyed together to make brass, and the tool had some brass fittings, so you can see that we have the zinc there and some copper to go along with it. I looked for arsenic because of some smells that I thought I recognized, but that wasn't it. Cobalt, there didn't seem to be much of any cobalt there. Molybdenum, there was a bit of molybdenum, and there was quite a bit of manganese. So we also looked at chromium, all of which are elements known to be alloyed with iron to make steel. Okay, so I'll be the first person to admit that this was sort of a quick and dirty experiment. And I wouldn't say that we can pull any quantitative data out of it, but what I think we can say pretty confidently is that by treating a steel with some kind of an acid, we're going to risk releasing some of the alloyed metals that were in that steel. And many of those alloyed metals are toxic heavy metals like molybdenum and manganese and chromium. Things that you don't want to get on your skin or in your body. You certainly don't want your dog getting into it. Definitely should not go down the drain and should not be poured out in your backyard. The waste that is produced by using vinegar as a cleaning agent is going to be a toxic, hazardous waste. So maybe vinegar is not as innocuous as we thought it was. Now, that being said, I hope you enjoyed the video. I hope you learned something from it. And if you liked it, please press the like button or leave a comment. Let me know what you think so I know what kind of videos to make in the future.